Good morning, students. In today's class, we start up the today's class with the chapter 1, unit 3. So, in this chapter 1, unit 3, we'll actually discuss about the quantum mechanics. So, what is actually the quantum mechanics is all about? So, quantum mechanics and what is the use of the quantum mechanics to the engineering students? So, that actually we'll discuss in today's class. Quantum mechanics is also known as, first of all, what is quantum mechanics we'll deal with is also known as, please write it down if it is possible for you. Right, writing the running notes is very important to understand the subject. So please write it down. Quantum mechanics is also known as wave mechanics. See, again I'm repeating, quantum mechanics is also known as wave mechanics. Wave mechanics, right? So which actually deals with which which deals with which deals with with behavior of behavior of it deals with the behavior of microparticles. So particularly we deal with the behavior of the microparticles. And when I talk about microparticles, so the dimensions of the microparticle is 10 power of minus 10 meters. And also this you already know, this is also be known as 1 angstrom. So in the unit 3 chapter 1 we'll deal with the quantum mechanics. So quantum mechanics is also known as wave mechanics, which deals with the behavior of microparticles, and these particles are nothing but dimensions of 10 power of minus 10 meters, such as electron, photons, um, neutrons, etc. So here particularly we'll just start up with our discussion with the what is the need of studying the quantum mechanics. So here the quantum mechanics background you need to understand. So previously whatever we studied, that is actually in the lower classes, that is classical mechanics. So we need to just compare that. What is the need of studying quantum mechanics? So classical mechanics has does not explain us. So this is the need of studying the quantum mechanics. So first of all, the classical mechanics does not explain us. It has not given us information of few theories, right? So we talk about few theories, right? Classical mechanics is completely deal with the macroscopic particle, macroscopic particles, right? Microscopic particles, right? So that is a distribution of the energy radiated of a black body, and also photoelectric effect. It doesn't explain anything about the photoelectric effect, what you have studied in your intermediate, photoelectric effect, and also Compton effect. Compton effect. So in order to understand this parameter, so what is photoelectric effect? So you already know, emission of electrons by metals when they are illuminated by some radiation. So the emission of electrons, photo is, what is that? Photo means light. So light, electric is completely different. Electric means electrons. So photoelectric effect deals with the emission of electrons by the metals. So when they are illuminated by radiations like X-rays, or the emitted electrons are photoelectrons, and this is about the photoelectric effect. So simply when someone asks you about the photoelectric effects, we say that emission of emission of electrons emission of electrons by metals, by metal. So electrons are emitted by a metal when it is illuminated by radiation. So by metal, and when they are illuminated, when they are when they are illuminated, please write it down, right? So when they are illuminated when they are illuminated by radiation, when they are illuminated by radiation, right? So these radiations, right, it may be x-rays or emitted electron or photoelectrons, right? So what is Compton effect? The Compton effect is what to define Compton effect? When x-rays see x-rays when x-rays are scattered when x-rays are scattered by electrons by electrons X-rays are scattered by electrons, it is found that the incident X-rays does not have same wavelength. When X-rays are scattered by electrons, it is observed that it is that observe that the incident X-rays X-rays does not have does not have same wavelength same wavelength same wavelength as scattered electrons scattered electrons. This is actually about the photoelectric effect and the Compton effect that we studied, right? So now, right. So now this is the difference. Now this particular concept has not been explained as clearly in the classical mechanics, which actually deal with the macroscopic particles. And here, the Compton effect and photoelectric effect deals with the particles which are not macroscopic; they are microscopic. So there is a very need of studying the quantum mechanics. So quantum mechanics is also known as wave mechanics, which deals with the behavior of microparticles, and these microparticles may be X-rays, may be electrons, may be photons, right? And so on. Now, so what is the next important thing that everybody should remember, that we need to discuss about the dual nature of matter waves and what is actually the matter wave is all about. So that actually will start off with this. Please make a note of all these things, right? Write the running notes, please. So do that for your understanding. So first, then the next aspect is dual nature dual nature of matter wave dual nature of matter waves. So the dual nature of matter waves are nothing but it deals with the uh, interference, which thing that is having dual nature. So here we'll discuss about the your interference and diffraction is nothing but it is having light. We say that light means photons. So it is exhibited by two types of nature, that is dual nature. So matter waves. So what is actually the meaning of matter waves? The matter waves and how these matter waves are different from the uh, what you can say the electromagnetic wave. So that actually we deal with the uh, aspect. Now here and also we read interference, diffraction, and also there is one more aspect, that is polarization. So interference, diffraction, polarization of light will deals with the particle nature, and also it exhibit the wave nature, right? So here, what is this wave nature? So I just will ask, this light is exhibiting this three properties. Tell us the light photons are exhibiting the property of wave. And the same way, see, when I talk about light interference, so I'm talking about light. So when I talk about light, I'm talking about photons. It's very well clear to you. So I start with this. Quantum mechanics is also known as wave mechanics, which deals with the behavior of microparticles, and these microparticles are having the dimensions 10 to the power of minus 10 meters, and that is 1 angstrom. The classical mechanics does not explain us regarding the microscopic particles. So Compton effect and photoelectric effect has not been explained by the classical mechanics. So that is a need of going for quantum mechanics. So first of all, we just take the example of light. So in the light, we have just taken the example of photoelectric effect and also Compton effect, wherein so the photoelectric effect and the Compton effect deals with the electrons and the photons, and the electrons and photons are here behaving as a particle nature. So in the same way, when you talk about the characteristic of light, so the light is exhibited by wave characteristic by the interference, diffraction, and the polarization. Here we are just comparing with the particle nature of light with the wave nature of light. So particle nature of the light is exhibited by light, and electrons are exhibited by Compton effect and the photoelectric effect, and the same light in the other aspect is acting as a wave. So that has been proved by interference, diffraction, and the polarization concept. So what it means, some particles at some time they are exhibiting a dual property of particle and also wave nature. So here, so that is a concept which has been suggested by Lewis. And now this is the reason that what the Louis de Broglie says that, so keeping in mind this, Louis has done is that Louis is a scientist for which he has awarded the Nobel Prize, dual nature of matter. So Louis de Broglie, Louis de Broglie, right? Silent here. L is silent. De Broglie suggested. So he suggested the idea of he suggested the idea of matter waves. He suggested the idea of matter waves. So he suggested the idea of matter waves, and he says that electron is considered as a particle. Here, what he says that he just taken one example. We are taking one example. So he says that electron is normally, so when you talk about electron, right? So electron is normally electron is normally considered electron is normally considered as a particle as a particle and also and also and also it exhibit and also it exhibit wave like wave like properties, right? So wave like properties, right? So wave like, hence he formulated hence he formulated the equation related to the what you can say wavelength of the light of the electron. Lambda is equal to h by p. So I will show you how this you have studied in intermediate, right? So this intermediate concept, in the intermediate you have studied about lambda is equal to h by p. So this particular concept has been very clearly derived. Actually, this has been derived, right? How we got lambda is equal to h by p, that actually we are going to derive here. So I think that you got a clear idea. Louis de Broglie suggested the idea of matter waves, and the electron is normally considered as a particle, and also it exhibit wave-like properties. And these wave-like properties is given by mathematically lambda is equal to h by p. And you know that when I talk about light radiations, so there is electromagnetic wave. So he says that how these electromagnetic waves is equal to matter waves. We say that the particles which are exhibiting dual property. So Louis de Broglie suggested that the matter waves are nothing but the particles which are exhibiting two nature of what you can say two natures. One is particle nature, and also they are also behaving as a wave nature. So electrons sometimes behave as a particle nature, and sometimes it behaving as a wave nature. So such particles are come under the category of matter waves. This particular concept has been given by de Broglie, and he has given the analysis, he had done the analysis. So here is in the analogy between the electromagnetic wave. He says that analogy, please write it down. Electromagnetic electromagnetic wave and the matter waves. Analogy between the electromagnetic waves and the matter waves. So electromagnetic waves, you know that behaves like a particles like electron behave like a wave. So this is called matter wave. So we say, what is actually matter wave? As you know that as electro magnetic wave, electromagnetic wave, electromagnetic wave behave like particles, behave like particles, right? So they are behaving as a particles, and also, and the electron and we electromagnetic behave like a particles, and which we clear it to you, and particles like, and particles like electrons, particles like electrons behave will behave like waves, behave like waves, and this is called, and the waves called matter waves. Someone asks you what is actually matter waves, so you can write this definition, right? What is matter wave? As the electromagnetic behave like particles, and particles like electrons will behave like waves. So we call such type of behavior of the wave nature of the particle, that is called matter wave. So now this particular concept, you need to understand what we know, that the properties of electromagnetic waves. So here what we'll do is that we'll just discuss about some properties of matter wave, right? So please write it down. I will just erase it starting. So this was the assumptions which has been made by the scientist. So I think that is very much clear to you, right? So you don't have any problem with this. We'll just start up with this. So instead of rubbing, we can just go to the next one, new, uh, blank document, create, right? So now, so we'll just deal with the properties. Now first of all, we deal with the properties, right? So just a minute, we'll just deal with the properties, right? properties of Properties of, in the examination will ask you properties of matter waves. Write some properties of matter waves. Matter wave. So what is the first property of matter wave? So according to de Broglie, what he says that, so what he says, the property of matter wave. So here the property of matter wave, in our first one, we just discuss the lighter is the particle, lighter is the particle, particle, greater is the wavelength, greater is the wavelength. The first property, greater is the wavelength. So if particle is very light, the wavelength will be very more. So that was the assumption, the important feature of the matter wave. So here we just discuss about this uh, property of this matter wave, right? So what we'll do here is that lighter is the particle, greater is the wavelength. And the second property that we are going to discuss in this phenomenon, what will be the second one? You see, second one will be what? The second one says that, see, second one, what the second one says? Now, second one, the property of matter wave, first property deal with the, what you can say, the first property is lighter is the particle, greater is the wavelength. And the other one, so the velocity, here say, what do they say? The velocity of the, what you can say, matter wave will be, what you can say, the property, the velocity of that particular particle will be more. You can just see this concept of matter wave. Please write it down. So that is the reason that I'm stopping here. Please write it down. If anything is there, please let us know for that. So please write it down. These are the important points that you have to remember, so that this not will be again right, will be explained to you. So please make a note of it, such that you should not have the problem. Now smaller is the velocity. Say, the first one I think everybody has written. So smaller is the velocity, smaller is the velocity, velocity, smaller is the velocity, the particle of the smaller is the velocity of the particle particle greater is the wavelength. Greater 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 is the wavelength. Please write it down. Is wavelength associated with it. Wavelength associated right with it, right, with that particular particle, with the particle, right. So this is the important aspect that you have to remember. So now the velocity, and there are few more important points. So this you can just read it, write it down. So it is there in the notes which will be given to you. So now here what we'll do is that the next aspect, so you have to write at least 4 points here. So you just remember this, the important point is lighter is the particle, greater is the wavelength, smaller is the velocity of the particle, greater is the wavelength, and the third property will be the velocity of the, we can say, the velocity of the velocity of right matter waves. Right, matter waves depends on the velocity of the particle, that it is not constant. Velocity of matter wave is not constant. Matter wave, the velocity of matter wave is not exactly constant, not constant, right, not constant when compared with the when compared with the when compared with the electromagnetic wave, when compared with the electromagnetic wave. This what you have to remember, right, electromagnetic wave. So now this is what and the other important aspect is the, now there will be the other important aspect, that what will happen when the velocity is very low. So when the velocity is very low, what will happen, the wave become completely indeterminate. So when we do it mathematically also, the v is equal to 0. So what will happen to the nature of the particle? So that is important properties of the what you can say matter wave. So please remember this for your in the examination he will ask you different properties of the matter wave, right. So what we will do here is that just I am just erasing it. Why? Because we just I told you that we will just derive the lambda is equal to h by p, right. I said how in the intermediate you just got lambda is equal to, you just remember that the dual matter waves, wavelength of the matter wave is given by lambda is equal to, how that scientist exactly got that lambda is equal to h by p, that actually we will going to derive. In the examination he will ask you uh, derive the de Broglie equation. So derive the de Broglie equation means you have to write this particular thing. Now what we'll do is that actually we'll actually derive the lambda value, wavelength, right. Okay, just a minute. Where does he take this? Okay, now the examination is he will ask you derive lambda is equal to h by under root 2me. Now if you this particular aspect will be asked in the examination, right, what will do? So okay, just a minute. See, in the examination he will just ask you to derive this. So how you are going to derive this? See, derive derive lambda is equal to h by under root 2me. So this will be the question, right? So what will be the solution of this question? So, right. So I will in this derivation we will also see lambda is equal to h by p also. So right. So now you know in the intermediate level, according to, please write it down, please, according to Planck's theory, Planck's theory, Planck's theory of radiation. So what the Planck's theory of radiation says? Planck's theory of radiation says it says that energy energy of a photon energy of a photon. So what is according to Planck's, E is equal to h nu. This is nu frequency, which is equal to h. Nu is what? C by lambda. So since nu is equal to, c is the velocity and lambda is the wavelength. I think everybody is having
So
familiar with this. So
these
E is equal to
methods
h
are
nu, nu is the
provided
frequency, h is the
for
Planck's
both the
constant,
hydrogen
E is
and
the energy of the
helium.
photon, nu is the
Presence
frequency.
of ions
Frequency can be
U
written
and
as
I
velocity of
in the
light divided by the
wavelength
wavelength. So
is the
nu is equal
presence
to
of
c by lambda.
electrons
So I have written h c
in
by
formal
lambda. So
example
now
of this
we
thermostat.
got E is equal
The
to
surface of
hc by
iron is
lambda.
usually
This
coated
is
with
equation
thin
number
film
one.
of iron
Okay, everybody.
oxide.
Now,
However, if this
now
iron
this is
oxide
according
becomes
to
weathered
Planck's.
from
So
sunlight,
according to
anodic layers are
according to
created on the surface
according
while
to
the well metal part acts as a
according
cap.
to
So when the metal
Einstein
is having any cracks in the core, the
Einstein
crack force will act
Einstein
as a
mass
hammer and there is a
energy
film surface that creates a
Einstein
cathode
mass
image
energy
in this case.
relation. Einstein mass energy
So
relation.
what
What the
happens in
relation
an
says?
anode?
Einstein says
Generally an
E is
anode
equal to
is
mc square.
considered to be a
I think
state
everybody is
switch.
familiar with this.
So
This is
iron is
equation
using the
number
electrons
2.
to produce
So
reciprocation.
by
Now oxygen
comparing
is absorbing from the
by
environment.
comparing
So at cathode, the
equation
liberated
1
electrons are
and
transferred to the
equation 2, by comparing
oxygen.
equation 1 and equation
So
2, that
in
is
the
hc
presence
by
of neutral
lambda
solution.
is equal to
So when it
mc
is
square. Can I
reacting
write
with
like this?
neutral solution, it is
See
releasing
this and this
hydroxide
get
that is
cancelled.
OH
I
minus.
think everybody understood
Now
this.
by adding these two
H
reactions,
by
we will get the
lambda
overall
is
reaction
equal
that
to
is Fe
mc.
plus 2 plus
Can I
Fe
write like
OH
this?
minus will be the product.
H by mc.
Now by adding these
Okay.
two reactions, we
So
will
H
get
will come
the
here.
COH
Employees.
negative that is ferrous
Lambda is
hydroxide.
equal to. Can I write like this?
If
H by
enough oxygen is
mc.
present,
Can I write like
ferrous
this? Okay,
hydroxide is
everybody.
easily
So, can
oxidized
I write
by
like this? Lambda
perimeter.
is equal to
That
h
means
by
if enough
mc is
oxygen is
moment,
present in the
mass, and
environment,
c is the
the
velocity of
ferrous
light. So, what I
hydroxide
can write here?
immediately reacts
So,
with
h by
oxygen to produce
p,
ferric
which is
hydroxide.
nothing but implies
This
p
ferric
is equal to
hydroxide is in the yellow
mv.
color.
So,
This
here
yellow color
v is the
component is
velocity and c is the velocity of light.
PCOV
When you talk about velocity of
free
light,
energy.
so photon
In the
mc
summary
lambda is
of
equal to h by
working
mc.
of
I can write
oxygen is
the
limited.
product of
But
momentum.
if
Momentum is product
oxygen
of mass and
supply is
velocity.
limited,
So I
the
think that you
output
got
product
from
will
where
be
this is a
either
derivation which is obtained
black
from the
anhydrous
Planck's
metal that is
radiation law and also
BeO. That means the
Einstein mass
black
energy
layer
relation. So
oxidation
right.
will take
So
place when the
actually now
oxygen
this is
content is
what
limited. So
the
due to the
derivation which has
rapid
been
the
taught to you
rapid oxidation,
the formula which
the
has been taught to
black
you in
layer
intermediate.
is forming
So in
on the
engineering
surface of
what we are just
iron.
moving forward,
That
de
is
Broglie
oxidation
wavelength,
corrosion.
de Broglie
So here
wavelength,
the anodic area will
de
be less
Broglie
and cathodic area will
wavelength
be more.
of
But
a
they are
particle.
in the
Please write it on.
hydrogen evolution
Of a
lab, anode will be more
particle,
and cathode will be less.
right, of a particle for
So now let us see the
relativist, for
differences between
which
emission
this you
corrosion
have to
and
remember,
kinetic
relativistic
corrosion.
mass, comparative
It is due to
relativistic
the
mass.
direct
So
chemical
what the
attack of
de Broglie
metal
says,
by
wavelength
metal.
of a particle for
So in chemical
relativistic mass
corrosion,
means
the
what?
metal is
So
reacting with
what
the
it
agent
says, I will
directly.
just show you.
But
So
whereas
now
in electrochemical
relativistic mass
corrosion, it is
is
due to
nothing
the
but it is
formation
actually
of
given by
larger number of
m naught
ions
by
at the cathode.
under root of 1
In
minus v square
electrochemical
by. Now this is
corrosion,
actually
anodic
the
part is
special theory
more
of
and
relativity.
cathodic part
So
also more.
now this for your
And the
understanding purpose. If you are
responsibility is
not
due to
writing
the
it, no
formation
problem.
of larger number of
This
ions
particular,
in
this
the
is for
cathode.
understanding purpose. Now when I say
But here heterogeneous
if now from
surface
here you can write
have
in the
less
examination,
corrosion.
this is for understanding purpose.
Corrosion
So
products
if E is
usually
the
get the place of corrosion.
kinetic energy, if E
Corrosion
is the
occurs at the anode
kinetic
where the product is
kinetic
unformed
energy
elsewhere. That means where the
kinetic
product is
energy
forming in between
of a
anode and
material
cathode,
particle.
there will
Which
be a
particle?
less degree of corrosion.
Material
It is a
material
self-controlled process, but it is a
particle,
it is also a self-controlled process.
but material
And
particle.
formation of mild soul
So E is the kinetic
and
energy of
higher
the material
sulfate
particle. So what the kinetic
is
energy is given by
altogether
E is equal
universal
to
cancel.
half
But here
mv
it is a
square. Everybody is
self-controlled
familiar with
process.
it. So the kinetic energy
To
is
follow the
given, particle is
electrochemical
given by
conditions,
any particle.
rusting of
So that is
iron
given by half
plates
mv square. So what I
involves
am doing here is
presence
that
of air
half
in moist
m
atmosphere
v square,
and
right?
the ground.
So just multiplying
So
m
here
and
the
dividing m.
rusting
The
of
value
iron
doesn't
is the
change.
presence of
So what
moisture,
it will
but
be?
whereas
Half
it rises
m
due to the
square
rusting of iron
v
in the
square
absence of water.
by
That
what
is
it
the
will be?
difference between
M.
chemical corrosion
I
and
think
the
that you got understood, right?
electrochemical corrosion.
So, and what is
So
this?
with this, we have completed the
This E
theory
is
of
equal
corrosion.
to
In the
half.
next class,
I can write
let us see
mv
the
whole square by
corrosion
m,
control techniques
right?
by
Since
emerging
P
from
is equal to
that is
mv, I think that you
galvanizing
got an
process.
idea. So now,
Along with the
so
galvanizing,
P
we
square
will
is
see
nothing
one more
but
topic also, that is
mv whole square.
corrosion control techniques
Clear,
in
everybody?
galvanizing.
So what I can write
Thank you.
here,
If you have any doubts,
right?
please ask.
Right?
Yes,
So
thank you.
E is equal to half mv square. So what is mv whole square? P square. So what I can write here? P square by m, or else I can write that as p square by 2m. Implies we got the value E is equal to p square by 2m. I think you got a clear idea. Now p square is equal to 2me. Implies what is p? P is equal to under root 2me. Now this is let us consider this is equation number 1, right? And this is equation number 2. So comparing, sorry, this is equation number 3. Let us consider this is equation number 3. This is actually our equation number 3, and this is equation number 4. Can I write like this? Okay. This is equation number 4. Clear? So comparing equation 3 and 4, what I can write here? Comparing, since what is this? Lambda, what is equation? By, you can write by comparing, by comparing, by comparing equation 3 and 4 and equation 4. What you can write here? See, lambda is equal to h by p. Instead of p, what I can write? Under root 2me. So this is the expression which is given by the de Broglie for find out the wavelength of the right matter wave. So now that is lambda is equal to h by 2mv. So what was our question? See our question. Lambda is equal to h by under root 2me. This was our question. So according to the Planck's theory of radiation, energy of photon is given by E is equal to h nu. So nu is the frequency. So nu can also be written as c by lambda, right? Where c is the velocity of light and lambda is the wavelength. So E is equal to hc by lambda we got. See, hc is equal to hc by lambda. This is equation number 1. According to Einstein mass energy relation, E is equal to mc square. This is equation number 1. Equation number 2. We compared equation 1 and equation 2 and we obtained the value lambda is equal to h by mc. See, c is the velocity of light, and here I can write v also here. V is the velocity of material particle. So lambda is equal to h by p. This is equation number, what you can say, 3. Okay. So now this is equation number 3, or you can just write it on, right, okay, equation number 3. So now de Broglie wavelength of a material relativistic particle. This is understanding purpose, right? I'm not, if you are not compatible with it, you please just make a note of it, right? If E is the kinetic energy of the material particle which is having mass and velocity, right? So if E is the kinetic energy of the material particle, E is equal to half mv square. You already know kinetic energy of any particle is given by half mv square. So half mv square. So I'm just multiplying and dividing with m. So what I will get? Half m square v square by m. E is equal to half mv whole square by m. So what is P? Momentum, product of mass and velocity. So what I can write? P square can be written as mv whole square. So I'm just substituting that E is equal to half P square by m. That is equal to P square by 2m. Can I write like this? So E is equal to P square by 2m. So now I got the value P square is equal to 2me. You can just see from this equation. So B is equal to under root 2me. So by comparing this equation number 3 and equation number 4, which is P is equal to me under root 2me, I'll get lambda is equal to h by under root 2m. Now this was the derivation which will be asking in the examination. So how this lambda is equal to h by under root 2me. So with this we'll just complete our talk here. So in the next class we'll just go for the next topic, that is the wave function and the de Broglie wavelength. Thank you everyone for your patience. So please, if you have any problem with the part of derivation or any topic, feel free to contact me, and also feel free to come for doubt sessions, right? Thank you everyone. Thank you for your patience.